this is the next section. This is going to be section P-4, lines in the plane and slope. So we have a lot of different equations and types of forms of equations. A lot of this should be review, like finding the slope, finding equations of lines, some of the differences terminology as well. So stick with me, we have a lot to look at. To begin with, we're going to look at the form of a line that you are most familiar with. And again, we're just kind of putting some names with what you've already done. But this is going to be the slope-intercept form of an equation. That's going to be the y equals mx plus b or c, whichever one you would like to use. But y equals mx plus b. So what you have here is, if they're asking you to graph the equation, we have 2x plus 1. So if we want to graph this equation, first we need to identify the different points in it. So first of all, we know that this m is going to be the slope, or the gradient, and this is going to be my y-intercept, so it's going to be 0, 1. The place that you always want to begin when you're graphing a line is going to be this point, the y-intercept. So we can go to the point 0, 1, make a dot there, and then we want to look at the slope. Again, the slope is going to be rise over run. At this point, it's not a fraction, so I'm just going to make it b1. So that means we would go up 2 and to the right 1. Or we can also go down 2 and left 1. So again, we need 3 points to make the graph. So again, with the ruler, of course, you would graph, this is the equation of that line. So it's fairly handy, the slope-intercept form for actually graphing equations. Now if we have, I should say equals 2, if we have the equation y equals 2, we don't have a slope, but we do have the y-intercept. So we will go to wherever y is equal to 2. We'll do this in a different color. Y is 2 at this point. So if y is always equal to 2, it's going to be a horizontal line. If it said x was equal to 2, then my line would be all the way on x is equal to 2. And again, it would be a straight line, so it would be always exactly on 2. So again, the slope-intercept, the one that you've been most familiar with, the one that we've always been using in this, is going to be helpful for actually graphing the lines. One of the other things that we'll move on to look at, again, I'm going to move pretty quickly because the book spends a lot of time, like how do you find the slope, how do you find all this stuff. You should know all that already, so if you don't, then please ask, but we'll kind of hit it as we go through this. They give you an equation. They say the total cost of production, so producing something, the C is the cost, and X is how many units that we're actually making, and how many pieces, or whatever. 25x, so 25 times the number of items we're producing, plus 3,500. And they want to know what's the fixed cost and what is the marginal cost. You might think, I don't know, I'm not sure what that is. The fixed cost is going to be if we make 0 products. If we make 0 products, how much money will we still need just to kind of function as a production line? So making 0 products, that would mean x is our products, number of products. So we plug in an x. My fixed products is going to be 35, this is talking about money, $3,500, $3,500. So if we had a graph, if we were doing this, then we would be no products. So if we had the products on this one, and then the money on this one, we would be at 3,500. So we have no items that we've made, but we still have to pay 3,500. So that could be like paying employees or rental for the place they're using, whatever that is. So then, the next question they're asking us is the marginal cost. So the margin is like per item, how much money are you adding to the cost of production? So in this case, that's always going to be the slope, or the gradient. So in this case, it's going to be $25. So that means for every product that we're making, we're going to add $25, So your margin will be $25. So whatever it is that's with X, that's the slope, will be the margin. Again, this is just a vocabulary issue, a phrasing issue to understand. And this is, again, business vocab, so to help you be familiar with that. So, again, skipping kind of a lot that the book is going through on this, but hopefully this will make sense. If we look at the next one, they're going to ask you, how do you figure out the slope from 2 points? Again, this should be review, but the equation for the slope or the gradient, y2 minus y1 over x2 minus x1. So again, we can call these anything we want, whichever one, as long as they're both 1, 1, 2, 2. We can substitute this in. We have 1 minus 0 over 3 minus negative 2. So my gradient or slope in this case would be 1/5. So again, we find the slope, the difference in y over the difference in x. So sometimes we see delta y over delta x. y2 minus y1 over x2 minus x1 is the same exact thing. So just keep that in mind. So again, that's the slope. They could also ask you to write the equation of a line. This comes up often as well in the IGCSE. The equation of a line with a slope m equals 3 with a point 1, 2. But they want it in point slope form. So we look over here. This is point slope. This is going to be useful. The point slope form is really used mostly for finding equations of lines. That's how it's most used. This one is used for graphing, this one's used for writing equations. So, and I'll kind of show you what this 2-point, it's called 2-point form, is. It's very much related to the point slope. Just depends on what information they give you in the question. So if we look at this one, write the equation for a line with m equals 3 with a point 1 to negative 2. Okay, so if we look at my point slope, it's going to be y minus y1 equals m times x minus x1. All we need is 1 point and the slope, so it's exactly what we're looking for with the information they gave you. So we take y is just the same, x and y are just x and y, minus, what's my y point? Negative 2, equals the slope, that's given to you 3 times x minus 1. So if we do this out differently, we have y plus 2 equals 3 times x minus 1. And that's going to be the point slope formula, or the form of the equation. Now, beneath that, it's kind of small to see, but I got the 2-point. The 2-point form is exactly the same as this one, but instead of just saying m, they're actually writing out the slope. Like, how do you find m? So the equation would look something like this. Y minus y1 equals, instead of m, we just have this. The equation for the gradient of the slope, y2 minus y1 over x2 minus x1 times x minus x1. So if they give you 2 points, instead of just 1, you can do this all at the same time. So this kind of saves you going back and plugging stuff in and doing stuff like that. So it is nice and helpful for something like that. So we have the point slope form for writing equations, the slope-intercept for graphing. We also have the general form, which is the top one. The general form puts ax plus by plus c equals 0. It always makes it equal to 0. So if you have something, if you have an equation that's, for instance, x equals 3, then it's going to be, it's the same idea. You would do x minus 3 equals 0. So it kind of puts it in relation to the context. The form is just a little bit different. Again, to graph it, you would put it on the other side. This is to be used differently if they ask you for the general form of the equation. So whatever is with x, whatever is with y, and then c is the one that just doesn't have a variable with it at all. Okay, so they give us another example. They say there is a company, Bausch & Lomb, it's actually an eye contact company, solution company. So they said their share in 1988 in the stock market is $2.38 per share. In 1989, it's $2.80 a share, so it's gone up. Write an equation to show, shouldn't say write an equation, to show the shares per year. So we need to figure out an equation that kind of puts all this together. It's kind of strange because we have 1988 and 1989. Those aren't exactly points. So in this kind of situation, what you want to do is just call one of them, I'll call 1988 0, like my 0 year, kind of my beginning year, and that year it's 238. And then this one, because it's 1 year later, I'll call that one 1, comma, 2.8. We don't have to do the 0 because we're not referring to money in the coordinate. So we've made our 2 points, so we need an equation. First, before we can write an equation, we need the slope. So we would find the slope. So again, if we want to call this x1, y1, x2, y2, we have 2.8 minus 2.38 over 1 minus 0. So we have 0.8, so we have 0.42 is the slope. So then we want to write this as an equation. I would probably go ahead, because it's an equation and it doesn't say specifically, we can use the point slope because we have a point and the slope. So say y minus y1, let's use this one because it's 0, 2.38 equals 0.42, the slope times x minus x1, which is 0, so y minus 2.38 equals 0.42x. If we wanted to graph this to see what it looked like, then we want to move the y over to the other side, so we write it up here, y equals 0.42x plus 2.38. So that would be the equation that would be joining the two shares. And you could plug that in to this one, and when you plug in x for years, you could figure out how much this share would be. It'd be like a predictor kind of thing. And that's kind of what goes in line with these two kind of words there, linear extrapolation and linear interpolation. Extrapolation you might have heard before. Interpolation could possibly be something new. In this case, it's going up. Like they're giving you 238, then it goes to 280. If we plugged in something else, it would be even higher than that. So if these were the two given points, this would be an estimated point. Obviously, we don't know if the share is actually going to do that. It's just an estimate based off of the past. If the given points are down here and your estimated point is not in between them, it's called linear extrapolation. So it's outside of the line. So your estimate does not lie between the given points. If, however, your estimate lied in between the 2 points, then it's called linear interpolation. Inter like between. So the estimate lies between the given points. So that's all that's really referring to. And that's what goes with this example. The only other thing that we have to look at, that we will look at in this section, is going to be the parallel and perpendicular lines. So I need to make some space. But you can see the parallel lines, and this is not something new. You know that for the line to be parallel with another line, the slopes have to be exactly equal. And if the lines are perpendicular, then they have to be the negative reciprocal of the slope. So we'll look at two examples of what this will look like and what kind of examples and questions you will see having to do with these two lines. Okay, almost done here. Nice and big white space. Change to a new location if you didn't notice. Give us a little bit more to do without having to erase. So if we look at the parallel and perpendicular lines, so let's say, we'll just hold this so it's easier. They give you an example that they say that to write an equation, okay, so we're going to do an equation of a line passing through 2, -1. Okay, so first we want parallel to 2x minus 3y equals 5. And then secondly, they want you to do a perpendicular to the same line, 2x minus 3y equals 5. Okay, so first thing we can do is figure out, well, what is this line here? So what I did was I took my line 2x minus 3y equals 5, because we need to figure out, well, what's the slope of this? Because we'll need that for the parallel and perpendicular, and then they gave you the point. So what I would do here is we would add, well, we can subtract 2x, so we have negative 3y equals negative 2x plus 5, divide by negative 3, divide by negative 3, we have y equals 2/3 x minus 5/3. Again, I can just take it like this to have it become equal, and that's going to be my slope. So I know that m, in this case, is going to be equal to 2/3. Then I'm going to take, because we said this is much easier for this one, the point slope form. So we have a point and we have the slope. We know the parallel, it's parallel, so the slope is going to be the same. So we take y, again, minus negative 1 equals 2/3 times x minus 2. So we have y plus 1 equals 2/3 times x minus 2. If we want to find, this is going to be the point slope form of the equation here. So if we, if we want to figure out what the general form of this equation is, we would multiply to cancel. We don't really, this is not really very helpful for us in the long run here, so I'm going to cancel. I'm going to multiply the 3 to cancel it in the denominator and say 3 times y plus 1 equals x minus 2. And I'll multiply it out. 3y plus 3 equals x minus 2. Move everything to the other side. Well, the general form, just to show you what that's going to look like, is we would have negative x, because we move it to the other side. Here, negative x plus 3y plus 5 equals 0. So that would be something. Oh, sorry, I made a mistake here. Ooh, that's pretty ugly looking. Just a second. I didn't multiply by the 2. We canceled the 3, but we still have 2 times this one. So when we multiply this out, 3y plus 3 equals 2x minus 4. There we go. So I move x to the other side, 2x plus 3y, and we add the 4. So we would get plus 7 equals 0. This is going to be the general form. Put it on this side. General form. And then if we wanted to put it in the slope-intercept, which is going to be helpful for us to graph, we again want y by itself. So we have 3y equals 2x minus 7 divided by 3, divide by 3, y equals 2/3 x minus 7/3. So this is going to be point slope. Sorry, that's a little bit messy to see. And that's going to be the parallel, the line that's parallel. So this is going to be A. Now if we wanted to find B, the perpendicular, we're going to do the same thing. We can use the same point, but instead of the slope being 2/3, it's got to be equal to, I don't know if you can see this, m1 equals negative 1 over m2. It's the negative reciprocal. So what this will look like, we have 1 minus negative 1, same thing, equals, instead of 2/3, we do negative 3/2. It's flipped, it's the reciprocal, and it's the negative times the same thing, x minus 2. Again, y plus 1 equals negative 3/2 times x minus 2. I'm going to cancel this and multiply by 2 to cancel out my denominator. So we have 2 times y plus 1 equals negative 3 times x minus 2. We'll multiply this out. 2y plus 2 equals negative 3x plus 6. We'll do the general form, so we'll move it to the other side. We have 3x plus 2y minus 4 equals 0. So this is the general form. And then for the point slope, we want to move everything away from y. So we have 2y equals negative 3x plus 4 divided by 2. Y equals negative 3/2 x plus 2. So that's going to be the point slope form of the equation. That just kind of depends on what it is that they're asking you. The last example that I want to show you is a little bit similar to the one that we looked at with the Bausch and Lomb, the shares, because it has to do with changing things to B, 0, and 1 and those kinds of things. So it's saying if you purchase a machine, let's draw a line here, purchase a machine for $12,000 and it lasts you 8 years. And at the end of those 8 years, you collect the salvage value, like what you can get basically for the pieces, is going to be $2,000. So salvage is $2,000. And they want you to write an equation describing the book value of the machine per year. So after 1 year, how much was it worth? After 2, because obviously things depreciate. So if they depreciate, they lessen in value. So if you buy a car and you drive it off the lot, automatically it's less valuable than when you bought it. It's the same kind of thing with this machine. After you buy it, it just kind of gets less and less valuable. So they want the equation to show how much less valuable is it going to be. So we're going to come up with points. We know that when they bought it, so I'm going to call this one 0. After 0 time has passed, I just bought it, it's $12,000. After 8 years, I know that it's going to be $2,000. So you can see how my points are with this. So again, before we write an equation, we need to do the slope of the line. Okay, so if we call this one x1, y1, and this one x2, y2, we can say 2,000 minus 12,000 over 8 minus 0. So that's going to give us negative 10,000 over 8, which is going to be negative 1,250. This is going to be my slope. So essentially it's going down by 1,250 each year. So again, we want to write an equation, they're saying. So we want to look at our point slope because we have points and we have a slope. So we have y minus, and then for this one we have 12,000 equals the slope, negative 1,250 times y minus 0. X. And actually, instead of x, we can just call it time, because that's what we're talking about, is the time here. So the value then would equal, because that's what we're looking for, is y is the value. The value is going to equal, if we kind of move this all to the other side, negative $1,250 times t. So instead of x, I'm just going to put a t to show the time, how many years have passed, plus $12,000. So again, this is all kind of money. So this, I just moved it to the other side to show that that's going to be added to it. So that's going to be, again, some new things, but not totally new. It's going to be built on something else. So we have quite a lot of new vocab, but I think that you guys will pick it up quickly. Go ahead and do for this section multiples of 4. Thanks.